0-1 knapsack using branch and bound. So what is knapsack problem? Knapsack is a bag where we want to fill the weights with maximum profit. So this knapsack problem we want to solve with branch and bound. Whereas branch and bound problems are design technique is used to solve minimization problems. Whereas knapsack is for maximization of profit. For that we will flip the values for positive to negative so that we can use branch and bound technique for this knapsack. Okay, so before continuing, let me explain as formulas regarding knapsack. So what is knapsack problem? A bag where you want to fill the weights. Okay, so those all weights must be less than or equal to m, that is maximum weight. Okay, and the profit is calculated with sum of pi into xi. Okay, so here we will calculate two profits, u and c, upper bound and lower bound. The upper bound is without fraction and the lower bound is with fraction, right? So these are the simple formulas where we use to calculate knapsack problem, and the xi is the solution vector which will have only 1 or 0, right? And the weights and the profits are given. Let us solve a simple example using branch and bound. Okay, so before starting, this problem can be solved using backtracking also, and this problem can be solved using branch and bound also. What is the basic difference? So in backtracking, what will happen? We will use depth first search. If we don't get a solution, we'll come back and expand the next node. If we don't get the solution, come back and expand the next solution. So that is depth first search technique, right? So what is branch and bound? Branch and bound is a combination of DFS and PFS. Depth first search and breadth first search. How? Let me see. So here we have a first elaborate all possible nodes, right? This is BFS. From this we use a technique called as LCBB, that is least cost branch and bound. Out of these all nodes, whichever cost is less, we will elaborate. Now assume that this cost is elaborate, then once again we will elaborate like this. Now out of these two, whichever cost is less, we will elaborate. Okay, so the branch and bound uses, okay, DFS and BFS both. Okay, so branch and bound is used for optimization problems, whereas backtracking is not used for optimization problems. Okay, they are used for enumeration problems. So let us solve knapsack problem using branch and bound. Okay, so let me take a simple example problem, right? Now in the example problem where the list of profits are given, the list of profits are 10, 10, 12, 8, 18 and the weights are 2, 4, 6, 9. Now let me start solving using least cost branch and bound, right? So here initially we will start from the root node. Okay, so initially we will have upper bound and lower bound. The initial upper bound is infinity. As we told, the branch and bound is used for minimization problem. Let us consider the maximization problem into minimization. That is, let us take the negative values. Okay, right. So the upper bound is initially infinity. Now let me include how many values can be included. Now assume initially, so assume the first item can be included. The first item included means what? 2 with profit 10. Second item is included 4 with profit 10. Third item is included with 6 with profit 12. Now what is the total here? 2 plus 4 plus 6, 12. Now remaining, what is the knapsack capacity? 15. You cannot fill the entire bag, right? Now what we take? We will take the remaining part, that is nothing but 15 minus 12, that is, 15 minus 12 is 3. So we will take 3 here. So 3 by 9 part we will take. Wait, that is 3 by 9 into 18 is what? 3 by 9 into 18. Okay, so which is nothing but 6. Okay, so let me total this profit. So the total is what? 10 plus 10, 20, 32, 38. Right? So the maximum profit is 38, including fractions, right? So we already told you we will consider fractions and without fractions. So the C is with fraction, U is without fractions. Right? So let me write here both values. So the without fractions, the answer is 32, and the with fraction, the answer is 38. Right? So this is first one. Now let us start considering the next step. Are we clear? Right. Now here what we do, let us consider next step. So in the next step what we do, considering the first item x1 is equal to 1. Right. So by considering the first item, what will happen? Just now we have solved considering the first item. The profit is what? Minus 38 and minus 32. So this is without fraction and this is with fraction. Right? That is C and U. So whenever we get the least, that is profit, we will update here. So here we will get 38. Right? Now what we do? Next. Now without considering x1 is equal to 0, what is the profit? Let's consider. So first one, don't consider 0, 0. Second one, 4, 10, 6, 12. Okay. Next, what is the knapsack capacity? 15. Out of 15, 10 we have filled. So the remaining we have to fill, that is 5 by 9. That is 5 by 9 into 18. Right. So that is 10. Right. So what is the total here? 22, 32. Right. So that is with fraction and without fraction. So with fraction it is 32 and without fraction how much? 22. Right. Now if you compare, which node to be elaborate? So whichever is least will be elaborated, because we are using branch and bound is minimization technique. So this node we will elaborate. Now once again we will elaborate. Okay. Now here what we do? x2 is equal to 1 by considering the second item. Right. So once again by considering the second item, we have already calculated in the previous step, which is minus 38 and 32. Here the same values will be repeated. Now calculate x2 is equals to 0 without considering 2. So what is that? Let's calculate. So 2 profit is 10. Don't consider the second weight, 0, 0. The third weight, 6, 12. Yeah. Now we have already completed 8. Then remaining is what? 15, 8 is completed. Remaining 7 we have to fill, because 9 we cannot fill. That is 7 by 9. That is 7 by 9 into 18. So that is nothing but 14. Are we clear? So we will fill like this. Right. So if you fill, what will happen? The first weight is considered, second weight is not considered. Right. 2 plus 6, 8 plus 7, 15. Right. So 10 plus 12, 22. 26 and 36 is the profit. So upper bound is 30, max without fraction is 36, without fraction it is what? 22. Now which is having the least? This one. Now let us elaborate this. Now always this cost should be compared with the upper bound. Right? So whenever this cost is greater than this upper bound, we have to kill this node. Kill this node. Okay, so kill this node, because 22 is greater than 38. Okay, 36 is greater than this 38 and 32 is also greater than 38. Kill this node. Now consider this. Now once again, yeah, x3 is equals to 1 and x3 is equals to 0. Right? So for your confirmation, let me calculate once again for this side. Now consider the x3 is equal to 1. That means consider first, consider second and consider third. That is 2, 10, 4, 10, 6, 12. Consider it. And the remaining part is what? 6 plus 6, 12. That is 3 by 9. That is 3 by 9 into 18. 3 by 9 into 18, that is 6. Okay, so 22, 38. So the same profit we got minus 38, and without fraction this is minus 32. Now don't consider the third weight. Without considering the third weight, how will you consider? Consider the first item, consider the second item, don't consider the third weight. When you don't consider the third weight, what is the remaining weight can be filled out of 15? 6 is already completed. Next remaining weight is 9. So the 9 can be filled perfectly and the profit is 18. Do we have anything further? No. So the total weight is 15 and here the profit is 10 plus 10, 20, 38. That is, so minus 38, and without fraction also minus 38. Now among these two, which one we will expand? Which one will allow? Now if you consider, after considering x1, x2 and x3, do we have a space to fill x4? No. Now let me expand this. That is, consider x1, consider x2, don't consider x3. Right? Now we have two solutions. That is, x4 is equals to 1 and x4 is equals to 0. Now consider x4 is equal to 1. Now let me do it the same thing here. Consider the first item, consider the second item, don't consider the third item, consider the fourth item. That is minus 38 and minus 38. Now here don't consider the fourth item. So if you don't consider the fourth item, what will happen? Don't consider 1, consider 2, don't consider 3 and don't consider 4. That is, the profit is 20 and the weight is 6. That is minus 20, and so upper bound and lower bound almost both are minus 20. So which is having the least? This one. So this is an answer. So whenever you are continuing the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9. Whenever you are elaborating one by one node, always the answers must be compared with the upper bound. Whenever the cost is greater than the upper bound, you have to kill. That's why we have killed this node, we have killed this node, we have to kill. Now because this is 38, not greater than 38, we did not kill it, we have continued. And we cannot elaborate here fourth node. We cannot elaborate the fourth cost by considering the three costs. We elaborated this. Are we clear? So this is about 0-1 knapsack using branch and bound. So what is an answer here? Now you consider the first item 1, consider the second item 1, don't consider the third item 0, consider the fourth item 1. Okay, so that is the profit pi into xi, that is 1 into 10 plus 1 into 10 plus 0 into 12, 0 plus 1 into 18, that is the profit is 38. You can also consider the weight also, 1 into 2 plus 1 into 4 plus 0 plus 1 into 9, that is 15. So which is less than or equal to m, and we got the highest profit. So this is using branch and bound technique for knapsack problem. Are we clear? So thank you. See you in the next algorithm.